My today's topic is epoxides for vinyl sulfones. This is what I'm going to explain to you how the epoxides are synthesized and how they are converted into vinyl sulfone, and then how the vinyl sulfones are important for the color chemistry for dyes. In my last lecture I've explained to you the reactive dyes. Let me give you a brief background. Reactive dyes, they are of two types. The ones are called cyanuric chloride based dyes. Cyanuric chloride based dyes means reactive dyes which carries cyanuric chloride as a linker. What is linker? I'll give you a brief intro a bit later. Reactive dyes, second, I give you an example that vinyl sulfone based reactive dyes. So reactive dyes are of two types. It was discussed in my last lecture. The reactive dyes are in fact those dyes which get fixed permanently with the fiber. They make a covalent bond with the fabric, cellulosic fabric, through a nucleophilic substitution reaction. So where there is a covalent bond mean there is a new product. Okay, so dye actually makes a new product when it gets attached with the cellulosic fabric, through a covalent bond. In that very perspective, those dyes which carry cyanuric chloride is one of the chloro group, reacts with the cellulosic fiber through nucleophilic substitution. So it gives actually it generates a covalent bond. So then that becomes a cyanuric chloride based reactive dyes. Lecture number 1 on reactive dyes clearly explaining this type. Then I'll explain to you vinyl sulfone based reactive dyes, what they were. I give you an example that this group is called vinyl sulfone. Vinyl sulfone. This is vinyl, this is sulfone, and in very specific case this R could be some sort of a dye. So such dyes do react with the fiber through this alkene moiety. This double bond reacts with cellulosic fiber and it creates a permanent bond over there. So vinyl sulfone based reactive dyes has also been explained in my lecture number 2 on reactive dyes. Then we discuss about this preparation of vinyl sulfone, how they are produced, how they are produced from epoxides. This is what I've explained to you guys. Explained to you about the reaction of epoxides with the lithium bromide, and then some sort of the sulfone groups. It may react over here and then it undergoes a ring opening reaction. The reaction actually starts with due to an interaction between oxygen and the lithium, because the lithium metals are electron deficient. So consequently what happens then, we receives vinyl sulfone with these R groups, which are supposedly a dye molecule in this case. So this is how the vinyl groups are generated. As I've just explained, they are produced from epoxide. So how the epoxides are produced? So that they can be used for the preparation of vinyl sulfones. This is what I'm going to explain today. So the title is Epoxides for the vinyl sulfone based dyes. So this is needs to be keep in mind how epoxides are produced. Once you produce epoxide, how further it could be converted into vinyl sulfone, and then vinyl sulfone along with the dye could be used as a reactive dye. Various methods are available for the preparation of vinyl sulfones, for the preparation of epoxides. So I'm giving you just few examples. Alkenes, to react with bromine water, bromine in the presence of water, So what happens then? We have an idea. It is supposed to undergo bromination and then the subsequent hydroxylation over there. So this is how the product is supposed to be. Then further, an introduction of a strong base like sodium hydroxide, it abstract proton from the hydroxyl group. I can write it this way. Resultantly, it attacks over there, and then this bond is moved between oxygen and carbon, kicking the bromo out. It's a sort of a nucleophilic reaction, specifically SN2 reaction over here. This negative charge attacks at this carbon and kicks the bromo out. So one could have this sort of an epoxide. So what are the other products are supposed to be sort of water, and one can have sodium bromide, So this is how this epoxide is generated. It's an alkene. An alkene could be of any type. An alkene could be of any type, Let's say it's a simple alkene, or it's a part of any ring structure like 5-membered, 4-membered, 6-membered structure. So accordingly, one can accordingly draw the structures. So this is how one of the method where you can produce epoxides. Once you have produced this epoxide, so you need to bring in lithium bromide. This lithium develops an attraction with oxygen and produces a ring strain and results in ring opening. Okay, once you bring in any other sulfone, it can attack over here and these rings open, and further subsequently the removal of proton, it gives us the vinyl sulfone. So this is how you can produce a vinyl sulfone. This R is supposed to be sort of the dye, then it will be a vinyl sulfone based reactive dye. Let me show you another way. One more thing, that the alkenes, one very important alkene is available in labs. This compound is very much styrene, very much used in polymer chemistry, easily available in labs. So again, one can use bromine along with water So what happens at that alkene? Over here, then introduction of sodium hydroxide, leaving of the proton from the hydroxyl moiety, and then subsequent attack from here. So one can generate an epoxide with benzene ring, So this epoxide can further subsequently be reacted with the lithium bromide and then some organic sulfones, resulting in the opening of the ring and then subsequent extraction of one of the proton gives us corresponding vinyl sulfones, which are directly connected with the dye. So this is how the vinyl sulfones, could be, epoxide could be prepared in this method for the preparation of vinyl sulfones at the end. Epoxides actually generally produced from the alkenes. Various methods are available, just told you, explain a single method over here. These are actually there actually fields, the ring strain. Due to the presence of high energy oxygen is there, they're always in a hurry to react with somebody. If anyone comes closer to this epoxide ring, somebody who can develop an attraction with oxygen like lithium did in just discussed example, that results in the opening of the ring, and that opening of the ring actually proceeds for the formation of vinyl moiety from the epoxides. The attraction with the lithium, because the lithium is a metal, metals are supposed to be the electron deficient, so they develop attraction for the lone pair on oxygen. Resultantly, it pulls over here the bond between oxygen and carbon, giving a chance for another negative entity to attack at this carbon. Resultantly, the ring will open, and opening of the ring will let down the foundation for the formation of vinyl groups. Those subsequently will be used in the preparation of vinyl sulfone based dyes. So this is one of the examples. Again, many different substituents can be part of the aromatic ring. Similarly, some aromatics, some sort of substituents can also be present on alkene moiety. If those substituents are present, they will keep moving till the end in the products as well. So those could be a simpler vinyl sulfones, or they could be bulky vinyl sulfone, depending upon the starting species, if it is a substituted one or it's an unsubstituted one. So it will lead to the formation of the same sort of the vinyl sulfones. So this is about this method, which is frequently used for the preparation of epoxides. The second method also uses alkenes, This time the reaction involves actually the per-acids. Per-acids are used in the reaction. We have an idea per-acids, one of the presence of the extra oxygen that makes normal acid into a per-acid, as it is in this case is So it's a per acid, reacts with alkane, alkene, in fact, what happens there, it attracts this proton, this bond moves over here between carbon and oxygen, this bond moves towards oxygen, and then this bond moves towards carbon. So this is how the reaction takes place. Actually, you can imagine there is a bond between carbon and oxygen. It's a carbonyl bond, carbonyl functionality. We have an oxygen here, and it's a hydrogen. So what happens here? So the bond between carbon and oxygen, double bond, that attracts proton present at the terminal, so it moves over here. Okay, so what happens actually, if it moves over here, so mean it becomes bond between oxygen and hydrogen. Here is your proton, R group is there. What has happened over here, this oxygen will generate a double bond. Yes, it is got a double bond over here. Then we can see over here, I can draw what has happened. This bond has moved from here to oxygen, so it will be like that. And from oxygen, bond between oxygen and hydrogen, it moved from oxygen to carbon, so it's something like that. So this will be the epoxide. The next is simple acid. So per acid has been reduced, has been converted into acids. It's one of the oxygen has been moved from this per acid into the epoxide. The oxygen atom has reacted with alkene to give us the corresponding product, that is an epoxide. So this is all about, it's the mechanism for this preparation. This is also a very widely used reaction for the preparation of epoxides. I can give you a glimpse again. Actually, this is an alkene, and we are to react it with a per acid. So an acid, presence of one extra oxygen makes it a per acid. So what happens? The double bond between carbon and oxygen, that is carbonyl functionality, in fact, that is carbonyl functionality, this one, carbonyl functionality, this bond moves towards hydrogen, it attracts hydrogen. As this bond moves up, this oxygen will become, this carbon will become positively charged, and as a result the bond between oxygen and oxygen will move into it, and this will be converted into like this one. Okay, and then as the bond between this oxygen and this oxygen will undergo a breakage, this will have an electron deficiency, and a bond deficiency, resultantly a bond from carbon will move to attack at this one. Okay, at the same time, when its proton has been moved to this carbonyl functionality, the bond which became vacant, due to the movement of the proton, will attack at this carbon to make epoxide ring. So this is how the epoxides are produced by the basic reaction between alkenes and peroxides. The peroxide has undergone a sort of reduction. Per acid has been converted into a simple acid. This will be the product. And again, as I've just told you earlier, The alkenes could be the simpler alkene as I've just written, or they could be in the form of rings, So if they are in the form of rings, they are supposed to be the same in the product, because only the double bond has to react with the oxygen from the per acid. The rest of the substituent, they has nothing to do, they will remain as such. So this is how you can produce epoxides. Epoxides could be produced from the alkenes. Two methods: one where we have used per acids, and the other where we have used halohydrons. Halohydrons. The reaction number one was regarded as halohydrons, reaction based on halohydrons. Let's say again we have given you a styrene molecule, and we ask you to react it with better to write the other way so you can comprehend so easily. What's this? We have an idea, it's a benzoic acid. Yeah, if we put in another hydrogen and oxygen, then it will be a sort of, it will become a perbenzoic acid. If you want to comprehend a bit better way, better to write that as well as a double bond over something like that. That's styrene could be written as well. Okay, just to keep the both towards each other so you can see what happens. So perbenzoic acid, and styrene, they are supposed to react in this acid, perbenzoic acid and styrene, as I've just told you, it acts over there. As this carbon will get positive charge, the bond between oxygen and oxygen will move towards here. In order to fill the deficiency of electron at this oxygen, the bond between this and this will move over here. As soon as this bond will shift at this oxygen, this carbon will also become electron deficient, because its electron has been moved to the oxygen. So what happens then? The bond between oxygen and hydrogen, it will attack at this carbon. So what happens as a result? We are supposed to get this side of epoxide with benzene ring. What has happened? The rest we are supposed to receive the benzoic acid. This is how they are supposed to be. The benzoic acid, epoxides have been generated from alkenes. I've discussed two methods. One is use of per acids, as I've given you example of perbenzoic acid, in fact, for the preparation of this very epoxide from styrene. Secondly, the other method was halohydrons. The method 1, based on the use of halohydrons which undergo nucleophilic substitution reactions. Use of halohydrons, So this is how they are supposed to be. This is how they are frequently used for the preparation of epoxide. Why we are interested for the preparation of epoxide? Epoxides we need here because those epoxides could be made to undergo ring opening reactions, and those ring opening reactions can generate the vinyl sulfones. And vinyl sulfones, as I've told you very in the beginning, that they could react with cellulosic fiber, and they can make a permanent bond there, they can develop a covalent bond there, and they can fix the rest of the molecule, rest of the dye molecule on the fabric. So they are called vinyl sulfone based reactive dyes. It could be a dye molecule, it's a vinyl sulfone, it's a vinyl. As I've told you, on that day the cellulosic fibers contains hydroxyls. Cellulosic fibers contains hydroxyl groups. They do react and develop a covalent bond with the carbons over here. So this is how a permanent bond is formed between cellulose and vinyl sulfone based dyes. The formation of this bond makes this dye a reactive dye, permanently fixed dye. So it's a class number 2 of the reactive dyes. First dye was reactive dyes based on cyanuric chlorides, and this is an example of reactive dyes based on vinyl sulfone. The dye could be any, as we have an ideas. They can be azo dyes, they could be non-azo dyes, could be generated from any sort of starting materials. So once the presence of azo group is there, it will be an azo dyes, vinyl sulfone based azo dyes, or sometimes they could be non-azos if you have a bond between carbon and nitrogen, and rest is other aromatic rings or substituents are around. So that will be non-azo reactive dye, non-azo vinyl sulfone based reactive dyes. So azo dyes could be vinyl sulfone based dyes or non-azo dyes, non-azo vinyl sulfone based reactive dyes. So vinyl sulfone could be introduced into any dye, and as the vinyl sulfone will be introduced, those dyes will become the reactive dyes. So with this one I will close the topic of the reactive dyes, because I've just given you an overview about what the reactive dyes are. Then I moved on to the types of reactive dyes. Initially I discussed reactive dyes based on cyanuric chloride. I explained how dye first reacts with cyanuric and then how cyanuric reacts with fiber, and how the cyanuric is called a linker between dye and the fabric. In the same fashion, I have explained the type number 2 of the reactive dyes, that is vinyl sulfone based reactive dyes. And in this case I've given you how the vinyl sulfones are produced. They could be produced from the epoxides. Then I moved back and I've explained also how the epoxides could be produced. I've discussed 2 different methods. One was the having a use of halohydrons. The other method involved the use of peracids. Okay, so both methods are frequently used. So I hope so you have got a better idea about the reactive dyes, then their classes, then in classes how they do react. If they are vinyl sulfone, then how the vinyl sulfone reacts with cellulose fabric, and if it's a cyanuric chloride based reactive dyes, then how the cyanuric chloride reacts with the fiber. So that's all about the reactive dyes. If you do have any question regarding to the reactive dyes, their types, their activities, their like the productions of epoxides, their ring opening reactions, their reaction with cellulosic fiber, please don't hesitate to contact me. You may put a question in comment area, or you may approach me through WhatsApp group. I will be happy to respond at the earliest convenience. I hope you got the message about the epoxide formation for the vinyl sulfones. Thank you very much for your kind attention. Assalamu alaikum.